What's up guys, it's LeetCoder. This is LeetCode 152, maximum product subarray. We're given an array like this one here, and we have to find the maximum product from a subarray within the array. In this case, the answer is 6 because the maximum product from a subarray is going to be 2 times 3, which is 6. So what's an algorithm that we can use here? Obviously, brute force would be checking all possible combinations, etc. That's way too slow. So how can we do better than that? Well, to do better than that, we need to track the previous product that we've already seen and compare it to the current maximum value. So what we want to do is traverse the array, store the current product and the current maximum. So we're on this 2 here, both max and product are 2. Then we hit this 3, max and product both become 6. Then we hit this -2. Okay, so now product becomes -12, but max remains 6. And then we hit this 4. Now product becomes -48, and our max is still 6. And at the end, we return 6. So in this case, it worked. However, if the array were reversed like this, then it would not work. And in fact, what it would return is 4. In this case here, we will actually want to go backwards from the right. So we'll start with 2 again. Max and product are 2. Then we go to this 3. They both become 6. Then we hit this -2, product becomes -12. Then we hit this 4, product becomes -48, and the max is 6. Now you'll notice if we went from the left, the max would have actually been 4 because as soon as it hits this -2, it would have been a negative number the rest of the time. So this algorithm is a 2-pass solution. First we traverse from the left, then we traverse from the right, and we take the maximum of both of those maximums. And that works in all cases. The tricky thing is when you have an odd number of negative numbers in the array, you don't know which side of the array is going to have the maximum. Therefore, you have to check from both sides. Now this gets a little more complicated when there are zeros in the array, but we can account for that later. Now, can we come up with an algorithm that does it in one pass without traversing the array twice? So we're going to have 3 variables here. We'll have our result, we'll have a current minimum and a current maximum. And we're just going to start out with the 2 here again. So 2, 2, 2. Okay, then we get to this 3. So the minimum is going to equal the minimum value of the current or the current times the minimum or the current times the maximum. In this case, it's 6. And we do the same thing for Imax, except it's the maximum of those. Again, 6. And then result is equal to the maximum of itself and Imax. So in this case, 6. Okay, then we get to this -2 here. Imin is equal to the minimum of the current or the current times the minimum or the current times the maximum. In this case, it would be -12. Imax, on the other hand, is the maximum of those values, which is going to be 6. And so result is again the maximum of itself and Imax, which is 6. And we do the same thing for 4, so this basically becomes -48, and nothing else changes here. So now let's try this for the other array that we had, which was reversed. Okay, first we start out with 4s all around. Then we get to this -2. Imin becomes -8. Imax doesn't change, result doesn't change. Then we get to this 3. Imin becomes -24. Imax becomes 3. And result still remains a 4. Then we get to this 2. Imin becomes -48. Imax becomes 6. And result becomes 6 as well. So you can see that one pass works for either of these cases. That's basically because we're storing the local minimum and the local maximum in every iteration. And the reason it's important to store the minimum is because if we had another negative value later in the array, then we would multiply that by the Imin, and that suddenly would become positive. So this -48, if we had, let's say, -1 at the end here, would actually become 48, and that would be the result. So this is basically taking the 2-pass solution and combining it into one, just by cleverly using some variables and taking the mins and maxes. And this is very common for problems like this, what's called dynamic programming. So before we get to the code, if you found this helpful so far, please give a like and a subscribe because it really helps the YouTube algorithm. And with that said, let's get to the code. All right, let's first do our 2-pass solution. So we'll define our left max here and that's initialized to the leftmost element of the array. We'll have our right max here, and that's going to be the rightmost element of the array. We'll have our left product, we'll store that in left here, and that's equal to the first element of the array. And then we'll go through, starting from the second element of the array, all the way to the end of the array. First, we want to update left, which represents the product. So we'll say left times equals nums at I, and then left max equals to the maximum of itself, left. Now, this doesn't quite work if there's a 0 in the array, and that's because if there's a 0 in the array, then after that 0, we're always going to get a 0 for left here. So instead what we want to do is check if left is equal to 0, then we simply update left to equal nums at I, else we do the multiplication. Okay, that's our left loop. Now let's do our right loop here. And the only difference really is the range. So it's going to start out from the length of nums minus 2, because we want to start at one left of the rightmost element. We're going until 0, and we're going backwards. Then all we do is we return the maximum of the left max and the right max. Oh, there's one thing that I forgot to change, and that's the 0 here. This needs to be the length of nums minus 1, because right is starting out on the rightmost element. There we go. Okay, so this is the 2-pass solution. Let's see if we can do it in 1 pass. So for the 1-pass solution, we need to store a result, which is equal to the first element of the array. We'll have our I max, which is equal to, well, first element of the array, and same with I min. Okay, and then we go through for each element, starting from the second element of the array. So 1 all the way up until length of nums here. We have our candidates here, and we'll call candidates like this. And it's going to be nums at I, so the current element, or I min times nums at I, or I max times nums at I. And then I min is equal to the minimum from the candidates. I max is equal to the maximum of the candidates. And result is equal to the maximum of itself and I max. And then we return result at the end. And that's it. So in this question, we basically needed to think about how we store previous values that we've seen into some kind of data structure. In this case, variables work just fine. The 2-pass solution does it in a way that has the left and the right product. The 1-pass solution takes the minimum and the maximum and uses the min and max functions to cleverly get the answer that we need. I would say that it's totally fine to start out with a 2-pass solution and think about how it can be optimized and then eventually get to this result here. And with that said, if you found this video helpful, please give a like and a subscribe because it really helps the YouTube algorithm. And I'll see you next time.